हाँ जी, कैसे हो सब? So, welcome to our first video of software engineering and problem solving 1.0, right? And today we will just cover how Java evolved, why like we are choosing Java, what is the history of Java, right? So first things first, why we are choosing Java, right? So the thing is ki Java is constantly evolving, right? Every year or so you will see that Java is rolling out their new version. They are coping up with Golang and other new upcoming modern languages, right? So this thing clearly indicates that Java is flexible, they can adapt, and they introduced very good things in recent times. That is key. Basically, they introduced virtual threads. Now they are compacting the syntax of Java and so yeah, Java we'll choose because first of all you will get a lot of learnings in Java, right? It's not as abstracted as JavaScript is. And the second thing is it's highly, compatible with C++ people. So we'll switch back and forth in C++ also in mid. Because see, most of the things which are, industry level, let's take an example of machine learning algorithms, right? So even the ML algorithms are coded in C++, right? Because of the performance. So the thing is, if you want to go in depth, you have to have, the knowledge of good languages. So that's why we are choosing Java, a middle ground, which is not too abstracted like JavaScript and which is not too complicated to start with like C++, right? So that is one of the reason in Java. Now the people who are targeting jobs and internships, well, Java goes hands in hands with job, competitive programming, and your development and DSA and system design, right? Everything you can do in Java. So that's one of the reason. So this, I think you have already went through our previous video of Think It Club, which is our community where we are gonna host weekly sessions, live sessions, where we'll address your doubts. We'll invite some experts to answer your doubts. So why and how of joining the community is, I think, cleared, right? The people who are new to our channel, they can refer that video. I'll attach somewhere here. And yeah, so this cohort will be 1 year long at least. And we're gonna cover so many different paradigms of software engineering, problem solving in general, and we'll not keep AI in behind also, right? We'll go and we'll crash the AI also, right? We'll put AI in our software components, we'll use AI, we'll dig deeper in AI. So I think the motto is clear, right? I have cleared that motto in my last video only, but I am again repeating it that our motto is to build engineering mindset, right? Peer programming mindset. So don't join our community if you are already 5-6 years of experience and you consider yourself 10x of the peers that we have in our community or myself, right? So if you want to do peer programming, dig deeper in different concepts, solve problems, right? So then you can join the community. So without any further ado, let's start today's video, right? I will have, for most of the video, I will have just like this, right? Where I have noted down the points. So this is my memory bank, okay? So I'll refer this memory bank whenever I'll need a direction. So yeah, so we'll start with history of Java, right? JVM internals in heading is there, but the thing is JVM internals will come later and we'll literally go through each and every detail of JVM, right? So before starting the video, this video is about history of Java, right? Why we are using Java, that I have already cleared about. History of Java, and then the next step is what tool set we are using for starting, right? The IDE, the prerequisite, and the setup, the OS, everything, right? So this is Windows. I am currently on Windows. So a history of Java is basically Java is a high level. So every language is high level is instead of assembly, right? So assembly is not that high level as compared to other languages because assembly is literally a low level language. But high level means it's not that like in English literal sense, high level means which is at highest level. But the thing is, high level here is key that which is abstracted, which you don't know, but how it is working under the hood, right? Object oriented, though it is not completely object oriented programming, you will know that what object oriented programming is in our further videos, but let me tell you that object oriented programming is a programming language where we have everything covered by objects or classes, right? But here there are some things which are not directly related to objects, right? Like 4-bit int, or I would say long, double, float, all these primitive types, they are present in Java, and that's why it's a semi object oriented programming, but still you can call it OOPS programming language, right? So this language is famously known as Vora, write once, run anywhere. So basically this language doesn't run on directly to your host, it doesn't go directly to your host machine. So basically, let's suppose my current host is Windows. So my Windows machine, my Windows operating system, right? And in like beneath of my operating system, I have some resources like RAM, like CPU, like SSD, some storage, etc, etc, right? So the thing is ki other languages like C, C++, they run directly on directly on your host machine, which is they will directly call any system call. What are the system call and all, you will know, but they will call everything through your OS or so, and they will run directly on your OS, on your resources. Their executable will go directly into your RAM, right? So that is the difference, is that Java at that time Docker was not there, so Java is meant to run anywhere, right? So any host machine should have a virtual machine. Virtual machine here is JVM. So if you have, let's suppose Windows will have its own distribution of JVM. If you are running Linux Ubuntu, right here, if you are running Ubuntu, then Ubuntu will have its own distribution of JVM. Now JVM is a kind of translator. So let's say this operating system understands Chinese and this Windows operating system understands English or Hindi, let's say, right? But here is a translator who knows every language, right? So whenever Java code will come here, though Java bytecode comes here, but for simplicity, let's say whenever Java code comes here, so JVM translates the Java code such that the host machine can understand it, right? So Java will not give its, there is a kind of conversion of code, which is key. First of all, you write a code, right, which is a simple text. Then that code get compiled to something else, right? In case of C, C++, that gets compiled and interpreted to machine code or assembly. Then assembler program is there. So basically what I'm trying to say is that there is no other middleware set up for C, C++ native languages, right? But for Java, this text will get converted to bytecode. So bytecode is the code that JVM understands, right? So it is a bytecode. Now this bytecode will go to JVM and then assembly, assembler, and then machine code, right? So that is one of the difference because of which it's a Vora, write once, run anywhere on any platform. Java code compiles to bytecode that can run in JVM or any operating system that supports running JVM, right? That is the same thing that I have listed down here. So it was developed by, so basically why I have written this guy's name is Q, because see, whenever you are reading or learning anything, make sure you respect its father, right? Its developer. So you can go and on Wikipedia and you can search about James Gosling and his background, how he came up with this idea. You can read more about him so that you can get inspired from him also. It depends on you, right? So in 1991, this project was initiated, and a bit of history. Why? Because if we are taking this language as our primary language for few months, then you should know the history, right? So in 1991, its name was Oak. Basically, James named it Oak because of a tree outside of his office. So yeah, you can write this like other points you can write in your own gist. But another good point is that author designed Java syntax like C, C++ because see, engineers at that time were familiar with C, C++ syntax, and it is a big plus, because of which when I started coding in Java, I learned so much that I was not able to in JavaScript, right? So yeah, that's why, because see, Java is more closer to C++. So Java 1.0 released in Java 2 version 2 is released in this year, and then Java Enterprise version came where you have support of APIs. So what is API? So basically whenever there is a popular example, whenever you go to restaurant, you don't go to kitchen directly to order your food, right? You ask some waiter to order your food, and that waiter will be a communication medium for you, right? So that communication medium is abstracting out, is basically hiding out the details that is going into the kitchen side, right? Because you don't have to know the underlying detail of kitchen, right? So that's what an abstraction means. Because see, my computer is an abstracted display, right? This monitor is an abstracted display. I don't know what is going behind the, like the pixels behind my display, but it is abstracted out. So that's what for me the API is display, right? So for similar things in software industry, we build stuff, right? We then abstract that stuff out. Because see, let's say I build some machine learning model, its name is YOLO, right? I don't want every software engineer to know the underlying details of YOLO. I just want them to know a basic thing, which is API, right? I'll provide them some doc or so, like how to interact with my model. So I will provide them the API, the medium, and the people will be able to communicate with my API using that medium, right? Like this. Similar is the thing with operating system. So operating system also abstract out a lot of stuff behind kernel or the underlying resource management. So whenever we play our music, we don't know how music is being loaded into RAM, how music is being loaded into RAM in chunks or whatever. We just know that we have clicked on the music player and we have just dragged and dropped the song into our music player, and all rest of the work is handled by our operating system, which is an abstracted way of communication and is an API for us, right? So lot of APIs were introduced in Java Enterprise version, right, in 2006 by Sun Microsystems. You can read more about Sun Microsystems. What is Sun Microsystem? Why they got acquired? So it's a basic detail that is very interesting to know. And some more version they came up with, like Java ME, Java SE, Jakarta, which is I think Java RX right now, I'm not sure. But yeah, that was it. More you can read about, but these are the things which I wanted to highlight, that why Java uses JVM, right? What were the core idea behind building Java, right? Why they built it like C++ syntax. So the next thing is, when they were designing Java, these were the principles, like it should be simple, object oriented. You will embrace the beauty of object oriented programming when we'll go into LLD HLD. See, Java, because of its object oriented programming, is very structured language. You will not feel any stress when going through a large code base written in Java as compared to C++ or JavaScript, because of its good navigation or intelligence, I should say, or LSP, whatever. But yeah, because of its good structure, I would say, because of its very good structure and abstraction, I should say, right? That is a good word. So it's more robust and secure. And you know that most of the banking apps, most of the fintech startups are working in Java, or old legacy bank apps are built in .NET because of C# or C like syntax, right? But the thing is, that is also, I think, object oriented programming, right? Let's see. C# is oops. Yeah, how to C# is an object oriented programming. That's about etc whatever. So due to these things, now people are moving to Golang, but we are still picking Java because Java will go in parallel with Golang. Both of them has their own disadvantages and advantages. And yeah, it must be architecture neutral and portable. So whatever host, whatever you are working on, its architecture should be like abstraction, put abstraction on everything. It must execute with high performance, like not as close as C++, but still the performance of Java is way more than JavaScript because of its concurrency, because of its multi-threading nature, right? It must be interpreted, threaded and dynamic, because see, most of the complex application, high throughput applications require threading, right? Some of the applications can be handled by async programming, but not always. So Java execution, so this is the high level gist that I'm going giving to you, right? But more detail like Java internals, JVM internals will come later when we'll code some basic examples, because that's how I have structured it, right? So one goal for Java was to run on any platform, and the solution for that was to compile to an intermediate code. So basically that's what I told you, that Java code is compiled to some intermediate code which is bytecode, right? And bytecode is understood by any JVM running on any operating system, right? That intermediary is Java bytecode. Instead of directly compiling to architecture specific, so instead of directly going from text to assembly to machine code for Windows, it converts to bytecode, because JVM, it's a responsibility of JVM to convert that bytecode to native code of host operating system, right? Java bytecode is intended to run by JVM running on top of the host machine, and users need JRE, Java runtime environment, installed on their host OS to run the Java programs. Due to this two-step compilation, like compiling first to bytecode and then interpreting or compiling bytecode to machine instructions, is bit slow. See, first you will go from Java like text, simple plain text code, to bytecode, right? And then that bytecode you will use, and JVM will be responsible to convert that bytecode to native machine code. And this process is slow because JVM itself has its own threads, its own stack, its own callable, etc, etc. And that's why JVM has the overhead of shifting things here and there for like little delay. But that's why it's still suited for big enterprise, because for a product based company, I always say improvement of latency in 10 ms doesn't make sense, because for RI, so 500 ms is the minimum, according to me, that 500 millisecond is the minimum lag that you will notice. Below 150 you'll not notice anything at all. So that's why there are always trade-off in Golang, Java, JavaScript, C++ that you have to take, either on developer productivity point of view, revenue point of view, bandwidth point of view, etc, etc, right? So it's not that there exists a language which is 100% perfect and every language has to comply with that language. It's not like that, right? So there is one thing more, which is JIT, just-in-time compiler, which compiles bytecode to machine code during runtime. So there are two things. One is compile time, one is runtime, right? Although we'll get into the details of JVM internals, and in our community you can anyways ask any question, right, in a live lecture. But compile time is when you are writing code, right? When you are writing code. So sometimes what happens is there is a lightweight compilation that goes on, or syntax checking, that when you are writing code, your compiler will tell you that syntax error or something like that, right? But the thing is there are two kind of things. First is you write code in text, you compile that code to something called assembly or bytecode. I'm talking about where the language is not into the focus. So I'm talking about for any language where your text is compiled to something that machine can understand. So let's suppose executable or binary. So in Windows, the executable and binary is exe file. Whenever you install any game, any software, it comes in exe. So bundled package, a bundled bag of different dependencies, files, directories that collectively forms a software, right? So that's what executable code is, where you will build some text, dependency of that text, different hierarchy of that text into a bundled bag, which is executable or exe file or DMG file for Mac, etc, etc, right? Or .o file for C++ compilation. So that's what. So this process is called compiling. So whenever you are converting your plain human readable text to machine code, machine readable text, I should say, it is compiling process. So in compilation itself, you will get some error, like let's say you imported something, right? And when you imported something, you will get this error in while coding only, because slightly lightweight compilation will be going on in the background. But if let's suppose you are not getting any error in compilation, if that error is prominent, right? Let's say it will come, but let's say you have thrown some exception, right? And you are not catching this exception, though you will get the syntax error. But if you try to compile, you will get a detailed error that this exception should be caught or something like that, right? So that's what. And then what happens is when you use this executable code and you load this code into your main memory, right? So okay, so this was a program. So executable, this is a program. So when you put this program in your main memory, which is your operating system will put this, will schedule this program into your main memory. This program will become a running program, and that running program is called process, right? So this process, when it is running in your main memory, that is called runtime. That time is called runtime. So any exception, let's say divide by 0 error, you are dividing, let's suppose any number x divided by 0, so infinity error or any error which is not caught at compilation time will be caught in runtime, and your application might crash in runtime. So that's why compilation time error are okay, but runtime errors are not okay, right? So that's what compilation and runtime time is. And yeah, so what happens is ki basically when you are running your program, so your JIT just in time compiler comes in and it tries to find some hotspot which code is, you know, is optimizable. So it will not compile a complete block, let's say it will compile a little block, it will compress that block. So that's what a JIT means. But you don't have to go in the internal details of JIT, JVM, because so this is our syntax of our upcoming videos. So anyways, you will see JVM internals, threads, heaps, stack, compilers, everything here, right? I'm just giving you an idea so that you can get familiar yourself and you can read more about it until next video comes, right? So Java performance is slow, I have already told you, but it's not that slow. Okay, it just written that slow, but you can write it as little slow, I'll say. Okay, introduction of JIT, compilation and additional feature to improve better quality. So basically Java is evolving time by time. So there is something called garbage collection also. So that will go in details of garbage collection also, and implementation of some garbage collector also as a project, right? And with every new version of Java, a new garbage collection technique is coming into the picture, and they are improving it year by year. Okay. And hotspot became Sun default JVM. And so there is a hotspot VM, right? That is the default VM, as they are saying that in 2000 for Sun Microsystems. So yeah, that was it for the history of Java, and I'm very excited to start this course or start this cohort or start this arc, whatever you want to call. But again, you can join our community, link is in the description, and see you soon in live building sessions, live doubt clearing sessions or expert session in our community. Bye bye.